All right, my name is Steve Danielson. I'm a programming writer with Microsoft, and this session is going to be about Windows Azure caching and how you can use it to maximize the performance of your cloud services applications. So I guess before we get started, well, let me go ahead. We're going to talk about a lot of different things here today. There's going to be some time at the end for questions, but because we've got so much stuff to get through, if you wait till the end, you might forget what your question is. So if you have some questions, just go ahead and raise your hand. You can ask it to me. I'll repeat it for the recording, and we can do it that way. So this can just be like just a conversation. Just imagine that you're kind of sitting over my shoulder, and I'm showing you how to do some Windows Azure caching. So what we're going to be looking at today is why you would want to use Windows Azure caching, what value it can bring to your applications. We're going to talk about how to do it. Then we're going to talk about the capacity planning options and tools that we have, so you know how big to make your cache, where to set some of the different settings that we'll be taking a look at. And then we'll take a quick look at the diagnostic options that are available. So once you get your caching application deployed, how can you monitor the health of it? How can you make sure that it's meeting the capacity needs of your application? So why would you want to use caching? Caching is a very well-known methodology for improving performance. Our hardware uses it, our CPUs, our browsers use it. And the main reason we want to use it is performance, scalability, and I don't have it on the slide, but cost and time. You know, if you can use caching rather than having to scale up a bunch of roles or federate your databases or things like that, then you're one step ahead of the game. So let's just take a quick look at an example of a real-world scenario of a state that had an election result website. And what they did was they built this website, hosted in the cloud using SQL database to report election results. And at first they deployed it for a local election. And what they found was using the architecture that they used, the users just overwhelmed the website. Too many connections. Every web page hit the database at about an average of 10 times. The database started slowing down. It started throttling and failing. And so this was just a local election, and they had intended to use this website for the upcoming presidential election. And so if it couldn't even handle the local election, what in the world's going to happen when we get to the full presidential election? So they called the Microsoft CAT team and said, hey, you know, guys, help. And based on the talk, what do you think the solution was? Windows Azure caching. So what they were able to do is come down and quickly implement Windows Azure caching. They preloaded all the election results into the cache, so the individual web pages didn't have to hit the database and then hit the cache and see if it's there and then go back to the database. They were able to scale out the web roles to be able to handle the traffic, but they were able to keep the same size database that they had, so they didn't have to go through any federation or any other custom partitioning schemes, which they didn't really have time to implement. And so as a result of using caching, they were able to drastically decrease the calls to the database. And basically, they were able to have a successful deployment. And you can look at the chart right here. The site went live at 8 p.m., and just within the first minute, they had tens and tens of thousands of calls. And they were able to handle that result by using Windows Azure caching. So this is just kind of a real-world example. So let's take a look at the architecture of caching. And there's actually two types of caching. There's Windows Azure Shared Caching, and then there's Windows Azure Caching. And of the Windows Azure Caching, there's two methodologies, co-located and dedicated. And so let's take a look at those three. And the first one we'll take a look at is the shared caching. And the shared caching was the original multi-tenant caching service that Microsoft deployed. And a lot of customers have used it and been able to use it to successfully improve the performance of their applications. But once it was out there for a little while, we started to get a little bit of feedback. The smallest cache, 128 megabytes, was $45 a month, and folks felt that maybe that was a little too expensive. The largest size cache that you could get was only 4 gigabytes, and that was $325 a month. And so other customers thought that was too expensive. And because it was a multi-tenant service, you had some throttling issues, bandwidth. And so what Microsoft came out with in October 2012 was Windows Azure caching hosted within the roles of your cloud service. And there's 2 flavors of that type of caching. There's co-located topology, which is where the caching is actually hosted within the existing roles of your cloud service application. So in this example, we've got an application with 2 web role instances and 2 worker role instances, and some of the underutilized memory and resources of the web role is utilized for caching. And you could put it on the web role, or you could put it on the worker role, or you could basically host it within any role on your cloud services application. Now, what's neat about this particular model is it's essentially free because you're already paying for those role instances. And if you've got underutilized capacity, then you can go ahead and put a cache on there. And it's a good architecture for smaller caches, and it's a quick way to get started and see what Windows Azure caching is all about. The other topology for Windows Azure caching is dedicated topology. And so here we've got the same cloud services application we were looking at a minute ago with 2 web role instances, 2 worker role instances. And for cache, we're going to go ahead and add a couple of cache worker role instances. And then all the memory and the resources of those role instances are used for caching. And so what's good about this model is you can scale out the cache independently of the web roles and the worker roles. So like in the scenario that we were just looking at, you could scale up the web roles to handle the web traffic, and if you needed to, you could scale the cache up and down independently. So whenever we talk about Windows Azure caching, this dedicated and co-located caching on the role instances is what we're talking about. And so for the rest of the talk, that's the type of caching that we're going to be taking a look at. Okay, the question is, do we have the same 120 megabyte restriction on co-located or dedicated? And I guess to go along with that, do you have an upper bound of 4 gigabytes? And the answer is no. You can have it much smaller if you want, but you also can get up into 100 gigabytes of cache, which is awesome, and it's really fast too. So let's take a look at some of the developer basics. There's a couple of parts to configuring caching in your cloud services applications, and that's to configure the cache cluster, the cache client, and then to go ahead and write the code that utilizes the cache. And we're also going to quickly take a look at some of the ASP.NET providers that can utilize Windows Azure caching on the back end. So the first thing you have to do is configure a role to be the cache cluster. And for co-located cache, that's just identifying which role you want to use. Or for dedicated caching, which is what we're going to use in this example, is to just go ahead and add the new cache worker role, and then just go ahead and configure the named caches and their properties. And so in this example, we've got 3 different caches configured within these cache worker roles. And we're going to take a look at some of these different types of different features as we go through the talk. So once you identify the cache cluster that's going to serve, or the role instances that are going to serve as the cache cluster, then you need to configure the cache clients. And basically, there's a really easy way to do that. We provide a NuGet package that you can install to the role. And what that does, when you install the NuGet package, is it adds the assembly references for caching, and it goes ahead and puts some entries into the web config or the app config of your client role. And then all you have to do is go into the config file and point it to the role instance that actually hosts the caching. So that's a lot of talk and a lot of slides. Let's just do a quick demo and we'll see how easy it is. Can you mix the cache between the web role and the worker role? I think you can only host one cache cluster within a single deployment, but you can have many different cache client roles that all talk to that same cache. Now, but within that single logical cache, you can have many logical caches. So you could have one small cache that had these features and these time to live and expiration policy, and another one that has different features. And we're going to take a look at that in the subsequent demos after this. So did that answer your question? Okay, so what we're going to do here is just create a real quick kind of a starter cloud service. And we're just going to have one ASP.NET Web role. So it looks like I might need some caching within my Visual Studio. Maybe caching whatever it is that it's... Okay, here we go. So now here's Visual Studio. We've got the one web role. And if we come down here at the Windows Azure project and we go into the web role properties and we go to the caching tab, we see we've got some different sections here. And all we have to do is to check this box that says Enable Caching. And literally at this point, once I save, I've got caching enabled on this role. Now, we really can't do too much with it. It's co-located. The default setting is 30%. And down here is where you can configure additional caches. And we'll be taking a look at that a little bit later on. So once I save this, my web role is configured as a co-located cache cluster host with 30% of the resources utilized for caching. So now I need to configure my cache client, which is going to be the same role because we're using the co-located topology. And to do that, I can just right-click on the role in Solution Explorer and pick Manage NuGet Packages. And if I type Windows Azure.caching, that brings 3 NuGet packages. The first one is the client configuration for the Windows Azure Shared Caching, which was the first one we looked at. And this one down here on the bottom is the Windows Azure Caching Memcache shim, which is a way to let applications that use Memcache to be able to switch over to use Windows Azure Caching, but to still use the same Memcache protocols and syntax that they've been using. The one we're interested in is this middle one, Windows Azure Caching. And so we're going to click Install, accept some licensing terms. It's going to grind away for a few seconds. And what it's doing now is adding the assembly references, it's writing things into the config, and it's making some changes to the service configuration file. And so if we close this, we can go take a look in the web config, and I'm going to zoom this up a little bit. Can everybody see that pretty good? I can, okay. So we see that a couple of new sections got added here, one for data cache clients and one for cache diagnostics. And as we scroll down through the file, we're going to hit commented out ASP.NET Session State Provider. So if you wanted to use the ASP.NET Session Provider that's backed by Windows Azure Caching, you could just uncomment this section and then comment this section up here because you can't have two. And if you wanted to use page output caching, then you just would uncomment this section right here. So if we scroll further down, we can see the data cache client section that was added. And what we need to do here is replace this with the name of the role that hosts the cache. And so now I've got a cache client configured that's pointing to the cache cluster that we just configured. And if I go into some code, and this doesn't really do anything, but we're going to create an instance of a data cache object. And there's a couple of different overloads here. And the sample that we're going to be using for the rest of the talk uses some of these different overloads, and we're going to take a quick look at that. We're just going to use the default constructor. And then items are added to the cache with a name value, key value pair. Okay. Okay, so I mean, this really doesn't do that much, but it's just an example of how simple it is to configure a cache. All right, question?
If you change from a process session state to cache session state, do you have to change the way you access session? In other words, is it like when you switch from a process to like SQL Server, you use the same model of session?
Okay. The question is, if you switch from the ASP session to the Windows Azure caching session, do you need to change any of your kind of programming methodologies for accessing the cache? I don't think so, but I don't know. Okay, you don't have to. It's just a simple plug and play. Same model. Okay, so we're done here. I'm going to go ahead and close this out because I've got a different demo that we're going to be using for the rest of the talk. And so, okay, so we just took a look at a little bit of code here, but this slide here just shows an example of a data cache client section, which the one we just looked at only had one section because by default it just adds one. Some of the features that you can use for caching are enabled through that caching tab that we looked at in Visual Studio, such as high availability and time to live and expiration policies. And some of the features of caching, like local cache, are configured through the config. And so here we've got two data cache client sections. One is the default and one custom client that's got local cache enabled. And so to use caching, you just new up an instance of a data cache. And actually, the first three calls down here all result in exactly the same thing. The first one gives you the default cache, which is the name of the default cache, and the default section. And these next two examples just explicitly configure that. The fourth example accesses the default cache, but it uses that custom client section, so local cache is enabled. And that probably seems a little confusing now, but the next demo that we're going to look at has got examples of all of those, and I think that'll help make it a little more clear. So putting items in the cache, you can put any serializable .NET object. And in this demo, we're using data tables, and so that's what we're using on this slide here. You just take your data table, put it into the cache. You can use the add method, which puts items in the cache but fails if the item already exists, or the put method, which will replace the item if it already exists. Then to access an item out, you just call the get method, look at the returned object to see whether it's null, and if it's not, then you can cast it to the desired data type. And if you want to explicitly remove an object from the cache, you can just remove it using the key. So this slide briefly talks about the ASP.NET providers. We didn't really have enough space, and so we're just showing the ASP provider snippet here. Uncomment this, comment out the other one, and then you just use your session just like you always normally would. If you want to use the page output caching, then you uncomment that section, and then at the top of the pages that you want to participate in that, you just add this directive right down here. So in this example, the pages are cached for 60 seconds, and every combination of parameters is considered to be a unique page to be cached. Okay, so the first demo we looked at was really simple. Now let's take a look at the demo that we're going to be using for the rest of the talk. And basically, it's just a simple statistics website which kind of hosts some fictional results for the NFL. And the NFL is organized into two conferences, or two divisions. I may be getting the terminology wrong. I'm not actually a big football fan. East and West. And then within each of those, there's eight groupings, and then several teams within each grouping. And if we go over to the database, we've got three tables: conference, division, and team. And so you can see we've got two conferences here. 8 divisions, and 32 teams. And so the caching that we're going to be taking a look at is optimizing the performance of this database. And so it's not really all that normalized or anything, but it's good for the purposes of this example. And a statistic website like this is a good candidate for caching because the games happen every Monday, and so you've got new results going in. But once they're in, they're essentially static, and there's really nothing new happening until the next week. And the demo that we're looking at, this is available for download on the code gallery, and the URL is on the slides. And so after the session's over, you guys can download the sample and run it. And there's actually instructions on code gallery that are going to show you a lot of the same things that we're going to be looking at today. So let's go ahead back here. And let's go ahead and clear the cache. Oh, come on. Okay. I've got backups for this. In fact, this isn't even going to be a problem. This literally just worked like 10 or 15 minutes ago when he was in here. They must have done something. That's what I'm going to say. So let me go to the emulator where I've got this running in the emulator. And when you click the data cache clear, it loads everything up from the database. And when everything loads up from the database, the headings on these conferences are going to be light colored. And so when they all come out light colored like this, we can see that they were loaded from the database and not the cache. And you can see a little statistics about how long the page took to load and whether we encountered any errors on the way. So now if I refresh the page again, you'll see that they all come up as a dark colored heading now, which indicates that the items came from the cache. And you'll notice that the times were a little bit faster because rather than having to hit the database, it was able to quickly grab the items from the cache. So now let me switch back over to the portal, and we'll just quickly take a look at the instances for this application. And so we can see here we've got 3 web role instances and 2 cache worker role instances. So for the bonus point, what topology is this for Windows Azure caching? Co-located role caching or dedicated role caching? Dedicated, all right. So let's go take a look at some of the code real quick. Basically, we've got a class called statsData. Well, actually, let's jump back to the default page. Whenever this page loads, it refreshes up the stats, and it calls this method on the statsData class called getDivisionStats. And so we're going to toggle over to this getDivisionStats. And what it does is it first tries to get the stats from the cache. And if it gets them from the cache, it goes ahead and uses them. If it can't get them from the cache, then it goes ahead and gets them from the database. And once it gets them, then it uses this helper method here to go ahead and put them into the cache. And that particular model is called the cache aside model. So now let's quickly go and take a look at the code that gets the items from the cache. And it's using the retry policy from the patterns and practices. I'm not sure the retry block or the error handling block. I can't think of the exact name. Okay. Okay, Topaz. And basically, we put it within this block, and it tries to read the item out of the cache. And if it fails for any reason, then it'll kind of retry using kind of an exponential back-off timeout period for a certain amount of attempts before it fails. So let's go into the properties for the cache worker. We see that caching is enabled. We've got dedicated role caching. And let's get down here and quickly look at these caches. We've got a default cache, a high availability cache, a notifications cache, and then a high availability with notifications. And these are the different caches that we're going to be using throughout the demo. And if we toggle back over to the application, we'll see that we've got these different checkboxes. So right now, the time to live, the default time to live is 10 minutes, but we're overriding that with a time to live of 5 minutes. So if we change this to 10 seconds, and we'll go ahead and clear the cache and then refresh the page. And I can go ahead and refresh a couple times. And if we wait just a few seconds and refresh, they have to be reloaded from the database. And so that's how the time to live works. And as we go throughout the rest of the demo, we're going to take a look at some of these advanced features here. So does anybody have any questions about this application? As we get further along, we're going to take a look at some of the advanced features. Okay, and this is the URL right there if you guys want to download the demo that we're looking at right now. In fact, here's the page for it right here. So this is my colleague Jason Roth, and he created this demo. Well, here we go. This is the sample that we're using right now, created by my colleague Jason Roth. And if you go here to this page, you can download it for yourself. And here's a little script that will help you to run the demo. Okay, so now we're going to take a look at some of the advanced features that are available in Windows Azure Caching. High availability, regions, local cache, and notifications, which are all pretty cool things. So high availability, here's a caching scenario with no high availability. And what we've got here is 2 web role instances and 4 dedicated cache worker role instances. And we're going to put a few items in the cache. And what happens when you put items in the cache is they kind of get distributed around the different role instances that make up the cache cluster. Now, if there's a catastrophic failure and one of these role instances goes down, then item B is lost from the cache. Well, it still is in the database or wherever it originally came from, but you've just lost the benefit of having it in the cache. With high availability enabled, we're going to put those same items in the cache. And when we do, the runtime creates a primary copy of each item and then a backup copy of each item that it puts on a different instance in the cache cluster. So now we've got 3 items in the cache, but they're all distributed among the different roles that make up the cache cluster. So now if we had a catastrophic failure, well, we lose that particular node in the cache cluster, but the items are still in the cache cluster. Now, when you try to access the cache cluster, you still may hit an error or two as the cache runtime says, oh, it tries to go to where it thinks item B is, and it's not there. But when it discovers that, it'll give you the backup copy, and it'll go ahead and redistribute those items within the remaining nodes while it brings the other node back up. And so let's take a look at a demo of that. Okay, so I'm going to check. Well, first we're going to do this demo without high availability. So I'm going to clear the cache and I'm going to refresh it. So now we've got everything in the cache, and we can see that we've got all 8 tables loaded out of the cache. And what I'm going to do is I'm going to use Task Manager, and I'm going to kill one of those 2 worker role instances. And this is them right here. All right, he's gone. So now let's refresh the page. And it might take a little bit longer because when it tries to access the item from the cache runtime is confused because that role is down and it's got to restart the role and it's got to shuffle around. But we've got our retry policy that's going to retry those calls for us. Okay, so now it came back, and we can see that some of the items were loaded from the cache and some had to be loaded from the database. And you can see that when we started to load this one here, that we ran into some errors along the way, and it took a little bit longer. And if we go down here, we can see this web page just kind of displays some of the exceptions. There's a temporary failure. Please retry later. 1 or more specified cache servers are unavailable. And so that's where the retry policy block is a good idea. So now let's enable high availability. And let's refresh the page again. And now we see everything's loaded from the cache. And we're going to go back in here, and we're going to kill off one of these worker role instances. In this particular demo, I had to switch over to the emulator before because something, probably when I was on the management page, I probably did something. But For this demo, we need to run it on the emulator because there's no real easy, convenient way to kill off a specific role instance in Azure, but it's easy to demo here on the emulator. So we're going to go ahead and kill this guy, and then we'll go ahead and refresh the page. Now, even with the high availability, it's still going to take a little while. There's still a little bit of trouble going on, and it's got to get things worked out. Okay, so now it loaded up. This time, this was the one that actually ran into the errors this time, but everything's still loaded from the cache. And so that's just a good visual demo of how high availability works. Alrighty. The next advanced feature that we're going to be taking a look at is regions. And a region is simply a logical container that you create, and then when you add items to the cache and associate them with that region, then they're contained within that region. Now you can tell by looking at the graphic here, we've got a custom region, we've got 3 items in the region, and they're all contained on one node of the cache cluster. We've got 3 other nodes that don't have anything on them. So what does that tell you? If you want to use regions, you've got to kind of handle, you don't just want to have one region and throw everything into it, because then that kind of negates the benefit of having a distributed cache across multiple role instances. So that seems like it could be a significant limitation. It creates some additional overhead for you. But the benefit of that is it enables scenarios such as tagging, searching, and clearing the items within a specific region. Because one thing that you can't do with Windows Azure caching is say, give me every single item that's in the cache. Or let me search everything in the cache and I only want the ones that meet this criteria X or Y. You can't do that on the cache as a whole, but if you create regions, then you can enable searching and tagging and clearing within those specific regions. And so how that works is you can create a region. In this example, we're using creating a custom tag, and we're associating it. And then when we put items in the region, here's an item in the region with no tag, and here's a couple of items in the region that have those tags associated with them. And then you can use the get objects by tag and specifically search and return items out of a specific region. And I don't have an example here, but you can also enumerate the items within a region. You can say, give me all the items in region A, give me all the items within region B. And you also can have items with the same key in different regions, because now the key and the region combine together to make the unique key. So if you need to have items with the same name, you can put them in different regions. So, and you also can clear out the items on a region. So I've got a demo of regions, and it's kind of we're not really using regions for a specific thing. What we're going to do is I'm going to enable regions, and I'm going to refresh the page. This is just kind of a neat demo. And then I'm going to kill off one of the instances just to kind of see what happens. Now, just because we've got 2 regions and we've got 2 nodes in our cache cluster, both regions could be on the same node. They could both be on the other node, or they could be divided across the nodes. And so when this page comes back, we may, okay, in this case, both regions were on the same node, and so they all went away. What I was hoping to show you was one side that stayed and one side that went. But we'll try one more. Okay, we're in the cache. I'll only try it twice. I actually had a screenshot last time, just in case. Just to kind of graphically depict how sometimes the regions can be on the same node or they can be on different nodes. Okay. Local cache is the ability to, in addition to having an item in the distributed cache, you can also save a local copy within the role that implements the cache client. And so in this example, we've got 2 web role instances, and one web role instance is going to retrieve item A. And when it does, it brings down a copy of item A, stores it within its own memory, and you can see here we've got a time to live of 5 minutes. So that means it'll hold this item in the local cache for 5 minutes. The next time it needs to get item A, it's retrieved from within its own local memory, and so it's very fast, even faster than getting it from the distributed cache. Now that copy is just for that web role instance. If the other web role instance needs an item of A, it's going to get a copy from the cache, but then that's going to save that copy for the next 5 minutes, and subsequent accesses are going to come from that same cache. Okay. All right. If A gets changed, what happens? That's kind of paraphrasing your question. Okay. So what we've got here, local cache, timeout based for 5 minutes. A has a copy, web role 1 has a copy, web role 2 has a copy. Let's take a look at a demo. Okay, now for this demo, I've got, okay, this is the URL for the load balancer, and it routes to, I've got 3 web role instances, and so each call to this page could route to one of the different instances. And so over here you can see right now we happen to be on instance 1, and if I refresh a couple times, okay, that time we got instance 2. If I keep going, we'll get them all. If I go down here into IIS Express, and I can see my 3 deployments. Let's get down here. I'll zoom this up a little bit. And you can see the IP address for the individual instances. And these IP addresses let you get behind the load balancer. And so I've got 3 pages loaded up that are behind the load balancer, and they represent instances 1, 2, and 3. So I'm going to enable local cache on instance 1. Then I'm going to enable it on instance 2. Okay, now you notice each time I refresh, the time essentially drops down to 0 because it's very, very fast to get the items out of the local cache. And so what we're going to do now is I've got this button here, which I've got to represent the home team of corporate, and we've got Seattle down here with 11 wins. And so I'm going to say Seattle wins on instance 1, and now Seattle has 2. But if I go to instance 2 and refresh, I'm still getting the old 11 because it isn't going to refresh until that 5-minute period elapsed, because that's what I had configured for local cache. So that's one of the downsides of local cache, is that you can get stale data. And so, which leads me up to my next feature, which is notifications. And notifications is a way to mitigate that possibility of stale data. And so I'm going to jump back a couple slides and see we've got timeout-based notification for local cache here. And in this example, we've got notification-based. So the cache is still the same with a time to live of 5 minutes, but we've got a polling interval of 30 seconds. And so that what that means is every 30 seconds, the local cache will poll to see if the data in the cache has changed. And if it does, then you can get more of an immediate update, and you don't have to wait for that whole 5 minutes. And so that kind of helps you to mitigate the that whole thing. So notifications are good for local cache because it can help you to get potentially faster updates to the local cache. It's not just for local cache, though. There also are programmatic notifications that you can get for cache, region, and item events, such as, I've got some listed at the bottom. If items are put into a cache, or if a region is created, or an item is replaced. And so we actually don't have a demo of that, but we do have a demo of notifications, but done with local cache. So we're going to check notifications and local cache. Refresh the, oh, okay, that's the main page. So or that's the load balancer. This is instance 1 and instance 2. So we're going to go ahead and refresh these. Okay, notice this time that they both have 12 now, because I guess when I was talking over that other slide, the timeout elapsed. So now we've got these items in the cache. Well, I like Seattle. I'm going to help them out a little bit. I'm going to give them another win here up to 13. Now I'm going to toggle back to the first instance and refresh. Okay, so that actually came really fast. So this is a good lead into, let's look at the application and see how we handle all of the different, how we map the different caching features. And we can actually take a look at the timeout, which I was pretty sure it was a lot shorter than 30 seconds in the app, because I didn't want to sit here for 30 seconds and be clicking around. So if we look in the web config, we see that we've got all these different sections. One for the default, one for default with local cache, which is what we used on the last demo. And then we've got a default notifications with local cache. Okay. Okay, the poll interval was 30 seconds, but I guess when I loaded it onto the cache the first time, that started that 30-second counter. And so then when I went to the other instance and talked for a while, that 30 seconds had elapsed, and then I came back. So does that clear to everybody? The demo was a little differently than I thought, but we could do it again. Well, I've actually still got a lot more things to talk about, so. But anyway, so here is how the features of the cache that are enabled within config are done. And if we look at the code for the stats data, we've got a big switch statement. Here we go. A static method that returns a data cache. And so based on the different checkboxes, we either create a cache client with a default, or the default cache, or a cache with the default but the section with the local cache, or the different things. So the point here is that some features of caching, like notifications, have to be done through config, but the other features, such as the high availability and the oh, not notifications, my bad. Local cache. Local cache is one of the features that you do in config, and some of these other features are done here. So when you have a method that news up a data cache, this one, when you have the checkboxes checked for high availability and local cache, you get this high availability cache, and you get this config section that has the notifications. And so, anybody have any questions on that? Oh. Why would you not use the notifications to get faster updating on your local cache? I guess it depends on how the needs of your application, how rapidly changing the data is, and how important it is to get the absolute most up-to-date data, whether 5 minutes is an acceptable interval or whether you need the 30 seconds, because there's additional overhead to do that polling for the 30 seconds.
For example, if you have static data like catalog data, fairly static, you'll get one to you just keep it in local cache.
Okay. Okay. Hey, do you want to get on? Do you want the microphone? Yeah, this is Bala. He's one of the senior product managers on the cache team, and he was kind enough to come help me out with some of the heavy-duty, hard questions. So, okay. Okay, the question was, if you have regions and high availability, does the whole copy of the region get put on a different web role instance? And yes, it does. Okay. The notifications is a way for the local copy, for the local copy that's saved on the client instance, to check to see whether its copy is out of date with what's on the actual cache cluster instance. Well, it only polls for the items that it's got a copy of in the local cache. And you've got a separate configuration. In fact, here we can see here, well, 100,000. Yeah, so if you had 100,000 items in your local cache and you're polling every 5 seconds, that could be a significant amount of overhead. But
if there's a lot of updates. Yeah, exactly.
yeah. Okay, cool. So up to this point in the talk, we've talked a little bit about why you would want to use caching, and we've talked about how to use caching, and how to enable the different features, how to configure a co-located role, how to configure a dedicated role. But how do you know what settings? How do you know how big to make your cache, or how many role instances do you need for the dedicated, or where to set the slider for a co-located role, and whether it even can support the cache that you want? And so in this section, we're going to talk about cache requirements, selecting a deployment topology, and then we're going to look at the capacity planning tool for both co-located and dedicated. So determining cache requirements. How much data do you want to put in the cache? How many objects? How big are the objects? And another thing to keep in mind is the frequency of the gets and puts, because each of the different VM sizes also has a bandwidth associated with it. And so if you're doing tons and tons of gets and puts, you could possibly exceed the bandwidth allocation for your particular VM size. And then you also need to keep in mind caching performance considerations. If you're using high availability, then every item that you put into the cache has got a copy made, and so each item takes twice as much memory. So you would need a cache twice as big to support the same amount of items. And the same thing with regions too. So these are all good questions, and they are actually up to you as the application developer, because you know how many items you need to put in the cache, and you know what your needs are. But the capacity planning tool can help you with what settings to use to configure a cache cluster that can meet your needs, kind of how to simulate some different caching scenarios and see what sort of configurations would be required. And so we've got a capacity planning tool, which is a spreadsheet that you can download, and I've got the URL here on the next page. And basically there's two tabs on the spreadsheet, one for co-located and one for dedicated. On a co-located, the question really is, do I have enough space on my existing roles to support a cache cluster? And where to set the slider to give me the amount of cache that I need? Now, the other thing you can use the co-located planner for is a lot of times somebody will come up to me and say, hey, if I set the slider at 30%, how big of a cache is that going to give me? And the tool doesn't directly tell you that, but you can kind of reverse engineer that. For the dedicated role planner, since you don't have existing roles because you're going to be creating new cache worker roles, it can help you determine how many instances, what size VM, and you can input the memory and some of the bandwidth, the amount of reads and writes, and it'll help you to decide. So here's a screenshot of the capacity planner for co-located, and it's got this input section at the top, and you just put in your existing configuration, put in the amount of desired cache, whether you want high availability, and then it'll tell you whether that's a feasible configuration for your roles and where you need to set the slider. The dedicated role one is a little bit more complicated. It's got 8 sections at the top where you can specify different data types, whether you want high availability, and these kind of can correspond to the different named caches that you can create. And let's just go ahead and jump ahead, and I'll just show you a demo, and then we can just kind of walk through all those different things together. Okay, so the first one we're going to look at is the co-located planner. And here we've got the VM size is configured to be small, and we've got 3 instances. And that actually corresponds with our cache worker role. Oh, okay, my bad. We'll come back to this in a second. We're not using co-located planning, so this doesn't correspond to anything. In this fictional scenario, we've got an application that's got a small VM size, 3 VM instances, and we want to store 700 megabytes worth of data in the cache. We don't want to use high availability, and so it just so happens that 30% would be the slider that would give us a cache capacity of approximately that size. Okay, question?
How is the data distributed when you get, say, 5, 10 instances? Is it just going to be on 2 of those instances for high availability? And when you ask for it on the 3rd or 4th instance, does it have to control through all the instances to find it? Or is it replicated across all of them?
Okay, the question is, if you're using co-located caching and you've got 10 instances of your web role, because a web role is the only type of role that supports co-located caching. That's right.
not true. But
No, backwards. A
Both of them
dedicated
do.
role can only be on a worker role.
Yes.
Co-located can be on web role or worker role. So you've got 10 worker roles and you've got co-located caching enabled. And so basically those 10 instances kind of join together to form a logical cache. And so when you put an item in the cache, the caching runtime indexes it and puts it where it thinks it needs to go. And you just talk to via the cache client and say, give me item A, and it knows where to get it. So you don't have to worry about distributing it around unless you're using regions, and then you just want to make sure you don't just have one region and put a billion things into it.
Yeah, it is distributed randomly. We have a hash function which basically randomly distributes it across all of the instances. If you use regions, there's a potential for a skew, because regions have to be collocated. If you have a region which is very large, then it's very likely going to sit only on one node, and that could get skewed. But if you didn't have any regions, you just had one cache that you're just using, and you had thousands of instances, objects, they're going to be distributed pretty much evenly across all of them. And if there isn't an even distribution, we, the back end, actually make sure that we even things out.
So the performance to get the data is not going to be great higher.
It will, okay, to be clear, the more and more you use, the more you put in, and as you get closer beyond the 30% limit that you have given, you will see a performance hit. Because if, for example, you said, I've given you 30% memory on the worker web role or the worker role to play with, and you end up putting so many things in the cache that it goes beyond 30%, or actually we won't go beyond 30%, but on the other hand, if the rest of the processes on those machines take up more than 70%, then the cache will get squeezed and you will see a performance hit. But at the same time, it's going to be gradually increasing in terms of, decreasing in terms of performance as you put more and more nodes. It's not going to be, it's not going to be the case that we take all of these are going to be exactly on one node, and that node is going to be suffering.
Now, if you just had one scenario with 10 instances and another one with 50, and you just put one item in the cache on each one, and then you withdrew that same item from the cache, I don't see there being any appreciable performance distance. And actually, this brings me to a good point that I forgot to demo on our very first demo. And that's a very important thing that you have to do when you're configuring a cache cluster, is you have to specify a storage account to use for maintaining the cache cluster runtime state. And the different node instances use this mechanism to kind of communicate. And if you don't specify this, when you deploy your caching application to the cloud, the caching roles will just endlessly recycle. And they'll start, and they'll restart, and they'll restart, and your application will never come up. And you'll be pulling out your hair going, what the heck? Because on the emulator, it all works just fine because it uses the developer storage to do that communication. But for deploying in the cloud, you've got to specify an account here to use for maintaining that runtime state. So I meant to show that on the very first demo, and I forgot, and this question helped remind me, so that was good. Okay, so that's the co-located. Now, to kind of reverse utilize this planner, if you said, well, what if I set it to 40%? How much cache will that give me? Well, you can just try some different stuff and see. So it looks like about 1,100. Well, 1,050. Well, so that's just a common question. If I set the slider to X, how big will the cache be? And a very, very super duper rough formula is, because each VM size has a specific amount of memory. And so you take 3 instances and 30% of that memory. But again, that's very, very rough. This tool is what's going to take into account the different overheads and the operating system requirements and so forth like that. So now let's jump over to the dedicated role planner, which is a little bit more complex. And what it does is it lets you specify up to 8 configurations of data size, the amount of objects you're going to put, whether you want high availability. And here you can configure the amount of operations per second that represent the reads and the writes for the cache. Then down here in the advanced options, you can specify a percentage of buffer in case you have spikes in your peak load. And then this option right here is interesting. If you specify yes, what it does is it basically includes an extra role instance worth of capacity in your cache cluster for cases where role instances go down for like Patch Tuesday and things like that. So you specify your requirements here, and what you can get down here at the bottom is possible configurations. And so here we've got a VM size of small with 3 instances, and that's the recommended configuration. And these other configurations would also be allow you to meet, and actually in the case of extra large, significantly exceed the requested capacity, but it still is a viable solution. So what this tool does is gives you kind of a starting point for where you can configure your app to start with, and then you can kind of just run it and just give it a try. And that actually leads us into the next part of the talk, which is about diagnostics.
Yeah,
Okay.
For high availability, do you have to have a minimum of 3 instances, or can you get by with 2?
I guess you could get by with 2, but 3 is recommended, a minimum of 3.
Okay.
Oh, and the question was, if you have high availability, what's the minimum amount of role instances for your cache to give you an adequate high availability?
So you will have, if you have 2 instances, basically we do test with 2 instances. What happens is when one goes down, the other one has to have enough capacity to take all of the data that is there. So you would be able to run it with 2 instances, but the problem is, and that's why you need the storage account. In fact, if you don't have the storage account that's given in, you can't actually make 2 instances work with high availability, because when you have network partitioning, both of them think that the other one's down, so they can take control. So with the storage account, we're actually able to make sure that you can have high availability with 2 nodes. But that said, you are basically you have to have enough capacity in both the nodes, which means you are running at less than half load. Right? Does that make sense? Mm-hmm.
Okay, I guess to quickly,
you can read it.
Actually, could you quickly summarize your question on that microphone? I didn't realize.
I've used the App Fabric cache before, and I wondered, is the underlying technology the same for the Azure cache? And specifically, are you still using like the same XML data contract serializer when you take the objects and serialize them into the cache?
Yes.
Okay.
Yes.
Okay, yes. And interesting to note.
We can take it offline in terms of how we actually measure what's the memory consumption going to be on the back end. We can talk about it, but yeah, fundamentally, it's essentially the same technology with a few additional features and integration, deep integration with Azure to make it a lot easier to use.
Okay, cool. All right. So leading in from kind of getting a starting point from the capacity planner for caching, once you deploy your application, how can you monitor the health of your caching application? How can you tell whether the cache is meeting the capacity, whether you need to scale it up or scale it down? And if there's having any problems, how can you figure out what it is so you know what to do about it? And so that's what we're going to take a look at in this section. The first thing we're going to take a look at, and this is really cool, with the release of Windows Azure Caching in 1.8, now there's a single diagnostic level that you can configure within your application. And when you set that one diagnostic level, it gives you a pre-configured set of performance counters, traces, event logs, and crash dump settings that you can use. So you don't have to configure, in the preview of Windows Azure Caching, you had to set the performance counters here, and you had to say which ones, and the crash dump settings here, and the logs here, and the traces here. Here you've just got a single setting, and so this chart here just lists what level of diagnostic is data collected for each of the levels. The default level is 1, and that just gives you baseline data that helps you to monitor the health of your application. But if something goes wrong, it'll give you enough indicator where you can scale up the diagnostic level to be able to get more detailed information about what went wrong. Okay, now I just said there was a single diagnostic level, but there actually is two. There's diagnostic level, which is for cache cluster diagnostic settings, and then there's the client diagnostic level, which is for the client diagnostic settings. You can set that in the service configuration, or you can set it in the portal. And what's really cool about this is you can update it at runtime just by uploading a new service configuration, or you can actually go onto the portal and just change it right there, and that change will be picked up, and you'll start to get increased data collection. And where all the data goes is into the storage account that you've configured for diagnostics. Now, in addition to the diagnostic levels, you've got to add a little bit of code in the startup for your roles. And so let's just take a quick look at what the diagnostic level looks like in the service configuration. There's the diagnostic level, the client diagnostic level, and you can also set it in the portal, and here's a little screenshot of that. Now, what you need to do in the on-start for all the role instances that are both cache cluster servers and cache clients is you've got to add this little bit of code. Now, the first and last bit of code is just standard diagnostic code. And in fact, if you weren't using caching, you could add these two bits of code without the middle part, or you don't even need to add them at all, because if you've got the right assembly references, the runtime will actually start that collection for you. But because we're using caching, we need a way to tell what the performance counters are, what the different trace logs and crash dump settings are. And so that's what this middle line does here. And so you've got to use it in conjunction with the other two. So if you don't do this, you deploy your app, you run it, nothing gets collected for caching. And you're like, well, where's my, I'm on diagnostic level 5. I should be blowing up my storage account, but I'm not getting anything. This is why. So once you deploy your app, once it runs for a little while, you can collect the diagnostic data. For the performance counters, you can view them in the portal, or you can download them from the configured storage. And for the traces, log files, and crash dumps, you can download from the storage. And, well, you can just kind of tell by the names of the different tables where the different stuff is. Now, if you do run into an issue, we'll just increase the diagnostic level, and you can just go right to the portal and do that. And then you'll get an increased level of data. Now, analyzing and viewing the data isn't really any different from any other Azure diagnostics. Just the only real difference for caching is how you can configure, and it's using the simplified diagnostic level. Now, what we've got in the pipeline is a set of troubleshooting guides that will be coming out pretty soon, which basically includes several sections of the most common issues with caching, kind of mapped and indexed by the various error codes. And when you run into a problem, you can use these guides, look at what the common solution is, and it'll tell you where to look to find out what's going on. And just keep your eye out. There's links at the end that have got links to some documentation and blogs and different things like that. And just keep an eye on that, because that's where that's going to be released. So I'm just going to give a real super quick demo, because I've got one more section that I want to cover, and I want to leave some time at the end for questions. Basically, we're just going to go into the portal. And if we go to the Monitor tab, we can see the monitoring for our NFL demo. And right now, we've just got the default stuff configured. And if we go to the Configure tab, we can scroll down. Here we can see the client diagnostic level. We can see the cache diagnostic level. And If we jump back over here to monitor, there we go. Add metrics. Now, this is another thing. I did something, and now the caching performance counters aren't showing up. So luckily, I'm going to do some trickery. Oh, look back there. I have a screenshot, and this is what they do look like here. And so you can see the different Windows Azure caching, and you just pick the ones you want, and when you do, they'll show up in here. And I've got, this is the page in the documentation, which has got a list of exactly what's collected by the different diagnostic levels. And if you go here, you can see all the different performance counters and the different things like that. And so this kind of helps you get hooked up there. Now, if we go into Visual Studio real quick, and I go to Server Explorer, and I can expand the Windows Azure storage, and I can see, like I can go into the performance counter table, and I can see some of the stuff that, well, these look kind of old. I guess it's been on here for a while. You know, I probably forgot to put that code in this app here. But anyway, this is where you can take a look at the performance counters and the different logs and the different things like that. So, patterns and guidelines. This is really just a recap of all the different things we've talked about today with one additional slide. And this is everything we've been doing so far has been kind of the cache aside model, where you try to get something from the cache. If it's not there, get it from the database, put it in the cache, and it's there for next time. The case study that we had at the beginning with the state elections, you know, if they did an architecture like that and, you know, 500,000 people hit the website all at the same instant, that actually would increase the load on the system, all this double hitting the cache and hitting the database. And so what they did is they had a dedicated worker role which would preload the data, put it into the cache, and then the web roles themselves would only try to access from the cache. And so that's another population strategy that you can take a look at. Configuration guidelines. Co-located caching is good to get started with. It's essentially free because you're already paying for those roles. It's good for smaller caches. But if you've got a really heavy-duty scenario, dedicated caching is probably going to be the way to go for you. If you need to keep different amounts of data in the cache, living for different times, different expiration policies or with different features, then you can use different configuration sections, kind of like what we did in the demo app. The demo app was a little contrived, but it does show you how to use different sections. Just keep in mind, local cache can give you the fastest performance, but you've got the possibility of stale data. If you put too much in the local cache, you can get client memory pressure. High availability, the trade-offs are, well, the benefits, more durable cache data, but it takes 2 times the writes because every item has to be written twice. It takes up twice as much memory. Same thing with regions. It gives you the ability for searching and tagging, but you've got to do a little bit of management yourself to make sure that you don't skew all the items into a single region on one node of the cache. The capacity planning spreadsheet can give you a good set of starter settings for your cache configuration. And then once you deploy, you can use the diagnostics that we looked at to see whether that particular configuration is meeting your needs. Level 1 is the default, but you can increase it as needed for troubleshooting, but then be sure to decrease it back down so you don't blow up your storage account. So, what we hopefully saw today was that caching is easy to use, easy to add, but it's got a deep configuration. You can do a lot of different things with it. You can handle a lot of types of scenarios by utilizing the different features. And you can use the capacity planning and the diagnostics that we looked at to see how everything does once you get it deployed. So here's some links to some different stuff. That's my email address right down there at the corner. So please feel free to email me. I've also put a link to the MSDN caching forum here, and I'm going to be monitoring that forum as well. So if you got any questions, if you want the community to look at them as well as me, you can throw it up there. If you want to email me directly. This is the capacity planning spreadsheet we looked at. Here's where you can download the demo we've been using today. There's several other caching samples on Code Gallery. How-to guide on Windows Azure windowsazure.com, and all the MSDN documentation is here. So here's a slide here, call to action, get started with Windows Azure. Drop by the Azure booth to participate in some Windows Azure Challenge. And here's the Windows Track resources. And I'm trying to get to, I think there's an evaluation slide. Here's some more resources. There we go. Completed an evaluation. Now this leaves us a little bit of time for questions. And I'm also going to be sticking around if anybody wants to talk to me. So does anybody have any questions about Windows Azure caching or anything we saw? Actually, you know what? I don't know if I can come down. Will my microphone... Actually, how about if we, since we're at the end of the talk, let's come to the microphone. That way we don't have to repeat every question twice. I know that's kind of a hassle, so I apologize. I'm just afraid if I come out there and let you use this one, it's going to start howling. Are these wireless mics? So we can't pass them around.
Is it difficult to write a read-through right behind provider for Azure Cache?
Is it difficult to write a read-through right behind provider for caching?
I saw there's an architecture for it, but I didn't know how complicated it was.
That's one that we have exposed for the App Fabric Cache 1.1. Is the same architecture, but we don't support it in Azure Cache right now. No.
You would have to write your own.
No.
Anybody else?
If it's a very key requirement, you can come talk to us. Yeah, we'll figure out how to do it. Yeah.
I think there might be a sample kicking out there somewhere of an ADO.NET provider which plugs into the cache.
I see.
And so it's kind of a simplified read-through right behind.
Well,
but I don't think it's officially supported or anything.
That, so.
All righty. Well, thanks for coming out to this session, everybody. I hope you guys learned something about Windows Azure Caching.
Thank you.